Newton analyzed the views of Galileo and other scientists like Kepler and Copernicus on motion and provided much deeper insights in the form of three laws. Newton's first law: every object continues to be in the state of rest or of uniform motion unless there is external force acting on it. So whenever the object is in uh, rest or in motion, it needs external force to start it or stop it. Inertia of direction: when a stone attached to a string is in whirling motion, the string is cut suddenly, stone will continue to move in the circular motion but moves tangential to the circle. This is because body cannot change its motion without any force acting on it. The inability of the object to change its direction of motion on its own is called inertia of direction. Newton's valid first law is valid only in certain special reference frames called inertial frames. In fact, Newton's first law defines an inertial frame. If an object is free from all forces, then it moves with a constant velocity or remains at rest when seen from inertial frames. There exists some special set of frames in which an object experiences no force, it moves with constant velocity or remains at rest. According to Newton's second law, the force acting on an object is equal to the rate of change of its momentum. F vector is equal to dp by dt. Whenever the momentum of the body changes, there must be a force acting on it. The momentum of the object is divided by p is equal to m into v. It is in most cases the mass of the object remains constant during the motion. The above equation gets modified into simpler form. F is equal to d of mv by dt. M is equal to dv by dt is equal to ma. F is equal to ma. The force and acceleration are always in the same direction. Newton's second law was a paradigm shift from Aristotle's idea of motion. According to Newton, the force need not cause the motion but only a change in motion. It is to be noted that Newton's second law is valid only in inertial frames. In non-inertial frames, Newton's second law cannot be used in this form. It requires some modification. In the SI unit of units, the unit of force is newtons, and it is denoted by symbol N. 1 Newton is described as the force in which the 1 kilogram of mass accelerates in an acceleration gives an acceleration of 1 meter per second square in the direction of the force. Newton's second law gives the correct explanation for the experiment on the inclined plane that was discussed. In normal cases where friction is not negligible, once the object reaches the bottom of the inclined plane, it travels some distance and stops. Note that there is a frictional force acting in the direction opposite to its velocity. As per Aristotle's idea, as soon as the body reaches the bottom of the plane, it can travel only a small distance and stops because there is no force acting on the object. Newton's third law is that the third law states that every action has an equal and opposite reaction. Newton's laws are vector laws. The equation F is equal to ma is a vector equation, and essentially it is equivalent to three scalar equations. In Cartesian coordinates, this equation can be written as fx of I, fi of j, fij vector f2k vector is equal to ma xi vector may j vector ma k vector. By comparing both sides, the three scalar equations are fx is equal to max. The acceleration along the x depends only on the component of force acting along the x direction. Similarly, for y direction, for z direction, the acceleration experienced by a body time t depends on the force which acts on the body at that instant on time. It does not depend on the force which acted on the body before the time, only on that time instant. So f of t, t is equal to ma of t. In general, the direction of force may be different from the direction of motion. Thus, in some cases, the object may move in the same direction of the force. It is not always true. Force and motion in the same direction, and force and mode not in the same direction. Case 2. Case 3 may be force and motion in opposite directions. According to Newton's law, so there are two forces. A book of mass m is at rest on the table. What are the forces acting on the book? What are the forces exerted by the book? The gravitational force mg is acting downwards on the book. Normal force, contact force exerted by surface of the book on surface of the table on the book. According to Newton's third law, there are two reactions forces exerted by the book. The book exerts an equal and opposite direction mg on the earth which acts upward. The book exerts a force which is equal and opposite to normal force on the surface of the table acting downwards. So the free body. So according to Newton's second law, F is equal to ma. So force is equal to mass into acceleration. Acceleration is given by F by m. F by m. Force is 5 Newton and mass is 2.5 kg. So acceleration 2 meter per second. For mass of 100 kg, force is 5 Newton by mass 100. So acceleration is 0.05 meter per second square.